Hello, CHS Algebra students. Today we're going to be talking about the difference between an arithmetic and a geometric sequence and how to identify those sequences. And so we're starting with these notes. The definition of an arithmetic sequence is a sequence of numbers with a common difference between consecutive terms. So you can identify an arithmetic sequence is usually like a list of numbers. So if we went like 18, 12, 6, 0, 6, and so on, oops, -6 is what that one would be, we can see that there's a common difference between these, that we're going down 6 each time. So it's a sequence of numbers with a common difference between the consecutive terms, like one term after another, it goes down by 6 each time. You can see this on a table of values by looking at the change in the x values, where this is going up 1 each time, and the change in the y values or the output values, where these are going down 6 each time. So you can see that common difference in the table of values. So you see that common difference. So common difference is the change in the y values or the output values. So, or the change in y over the change in x. And when we're dealing with a list of numbers, that change in x is usually 1. So we're not really skipping any numbers, but the output values is what it might change. If you looked at a graph of this, so at 1 it's 18, at 2 it is 12, 3 it is 6, and so you can see that these points all line up. They create a straight line. So it's a very linear pattern. So when you're looking at a graph, you're looking for a linear pattern or a pattern that makes a line. Now you don't want to connect these dots because there aren't in between values here. There isn't anything in between the 18 and 12 on in our sequence. They're just a list of numbers, but it does make this linear pattern where the points all line up. When we write the recursive formula for an arithmetic sequence, so we always start with what our first term is. So what is the first term or the 0 term in the sequence? And so here our first term is 18. So we always have to say where to start. Then we always say the next term is equal to the term that came before it. And this is going to be plus or minus C, our common difference, right? So our common difference is that number there. And I'm actually going to back up just a little bit here. Let me grab my whiteout because I want to make sure that I specify that this number that's getting written here is going to be a special value. So we're going to call this value B. So the B can be either the first term, like term 1, or term 0. Okay, and the C is that we add or subtract a common difference. Now, in your explicit formula, you're going to have something like f of x. It could still say f of n. That's okay, but I'm going to use x here. So f of x equals your 0 term. So here it does have to be very specific. When we're writing this, this has to be term 0. Term 0. So we don't really have the choice like we did in the recursive formula. We have to go to term 0. So to get to term 0, we go back to this point. So in which case we would add 6. So 18 plus 6 is 24. So our term 0 is 24 in this problem. So our term 0 is also known as the y-intercept. Okay. Then we add or subtract our constant or our common difference, sorry. So add or subtract the common difference. X times. That's how many times you're subtracting 6. So you're starting at 24 and you're subtracting 6 one time to get here, 2 times to get here, 3 times to get here, 4 times to get here. So that's what the formula gets written out as. Now, a lot of you have seen the slope-intercept equation written with these two terms switched. So you've seen it as cx plus b or mx plus b, and those are completely appropriate. They're the same. Um, they're the same message. Um, Addition is commutative, which means that you can trade places. Another word name for this slope or this common difference is slope. Or slope, or it's also known as the rate of change. These are all different names for that same thing. And we measure the rate of change by the change in y over the change in x, or the change in the outputs over the change in the inputs. And that is the arithmetic sequences, how to identify arithmetic sequences. So what you're looking for is a common difference. So you're either adding or subtracting the same number from each term. In a table, you're looking for that common difference on the output side. On a graph, you're looking for a linear pattern or points that line up to make a straight line. In a recursive formula, you're looking for something that adds or subtracts a common difference from your equation. So you're looking for a plus or minus right here. And in an explicit equation, you're looking for an equation with no exponents. And then we use the y-intercept and the slope. So if you were given an equation with no exponents, you would know it was an arithmetic sequence. If you were given a recursive formula that added or subtracted a number from the f of n minus 1, then you know it's an arithmetic sequence. If you're given a graph that has a linear pattern, you know it's an arithmetic sequence. And if you notice the pattern changes by addition and subtraction, then you know it's an arithmetic sequence. That is arithmetic sequences. Let's talk about geometric sequences. So a geometric sequence is a sequence of numbers with a constant ratio between consecutive terms. So if we go 2, 6, 12, 24, we can see that each number is being multiplied by, excuse me, by 3, because this is times 2. I think I made a mistake. And this is times 2. But this one was times 3. I think I have a mistake in my pattern here. I think this is supposed to be a 3. Easy enough to fix. So if we take 3 and we multiply it by 2, we get 6. Multiply it by 2, we get 12. Multiply it by 2, we get 24. So we have this constant ratio of multiplying by 2. So when you're looking at a table, you're looking for that same pattern. You're seeing the times 2, times 2, times 2 for each one of these. And if you wanted to check this side, they're always plus 1. So they're just going up 1, but this side is increasing by times 2. So you're looking for something that multiplies or divides a term to the previous term. So you're looking for a constant multiplication. I'm going to put a time symbol, multiplication or division of the same number. So you're looking for multiplying or dividing by the same number on a table. On a graph, you're going to be looking for something a little different. So instead of finding a linear pattern, you're likely to find a curved pattern, or you will find a curved pattern. 6, 12, and then 24. So it starts off kind of growing slowly, and then it starts to shoot up and grows really, really fast. Because 5 is 48, and then 6 is 96, which is off my graph. So I can't even graph that. So what you're looking for here is a curved pattern, also known as an exponential pattern. And the reason why, so it either grows quickly, so it starts slow and shoots up and grows quickly, or it starts up high and then decreases quickly and then kind of tapers off onto the end. So that's the other way it might happen. So it starts slow and grows quickly, rapidly, or starts high and decreases. Rapidly and then slowly. Okay, so on a table, you're looking for multiplication or division of the same number. On a graph, you're looking for a curved pattern. In a recursive function, you always start with your first term or that beginning term. So this could be term 0 or term 1. And the f of n minus f of n, or f of n equals f of n minus 1. So the new figure equals the figure that came before it times your constant rate or your constant ratio. So this is multiply or divide by the constant ratio. Now, your explicit function, what you're looking for in your explicit function is that it's going to have an exponent. So it is exponential. Okay, so what this looks like is you could have f of x equals, and if you go with term 0, so if we go with term 0, then you can write your constant here, and the exponent on that is just an x. So you still have your common constant ratio right there. Now, if you don't start with term 0 and you start with term 1 instead, so if we start with term 1, so if this is term 1, then when you write your exponent, you have to subtract 1 from it. So if you have term 1, that's not showing up because of the yellow. Let me write it in orange. Hang on. If you have your term 1, then your exponent has to be x minus 1. But the constant ratio stays the same. So that's just the difference between these two equations, is whether you started with term 0 or started with term 1. And this is an exponential equation, meaning that there is an x in the exponent, and that's how you can tell it's a geometric sequence. So from an explicit formula, if it has an exponent, then it's a geometric sequence. From a recursive formula, if you're multiplying or dividing, it's a geometric sequence. From a graph, if it's a curved pattern, then it's a geometric sequence. And from a table, if you're multiplying or dividing by the same number, then it's a geometric sequence. And just so that we have this number here, if we went back to term 0, we would have to divide by 2. So you're doing the opposite of going the other way. So we divide by 2, which would be 3 over 2 or 1.5. So that might be something you would use when you wrote your formula down here, and it might be something that it's just easier to use the term 1. If you have any questions, please schedule an appointment to meet with your teacher and get some extra help. Have a great day. Bye.